share my screen here. So if you're seeing my screen, you're seeing 4b. This isn't quite correct for, like, we wouldn't necessarily want to see it in this form, but whenever you see a second derivative on the left, that just means you're going to integrate twice. And when you integrate twice, you need two initial conditions, because you're going to have two constants. You get a constant every time you integrate a function. Okay, so with a little rearranging here, it's the integral d squared y equals integral 2x minus 1 over x squared dx squared. And this x greater than 0, not sure why this was put in. We'll maybe find out here in a moment, but that's just extra information.
Okay.
So on the left here, when you integrate the second derivative, you get the first derivative.
Okay.
And on the right, you have to use a power rule. So if it helps, you can rewrite it as this before you take the integral.
Okay.
So it becomes x squared.
Mhm.
And if that's not clear, let me maybe make that clear.
No, I get that.
Okay, all right. Whoa, that's bad.
Mhm.
Minus, and then this one maybe isn't as clear. You add 1 over -2 plus 1 plus c. Okay, so your answer here, and I'm instead of writing dy, I'm gonna write y prime. These are the same.
Okay.
Your first, after you integrate the first time, you get x squared plus, and this is x to the -1 over -1. The negatives cancel, and it looks like this.
Okay.
And then you want to use your first initial condition. It says y prime of 1 equals 1. You have to use it here. You don't wait till the end. It'll be much harder. You'll have to take a derivative, and you'll wish you had done it in this step here. So this number inside here is x. That's y prime. So 1 equals 1 squared plus 1 over 1 plus c.
Mhm.
So it looks like c equals -1.
Yep.
And that goes back into this line here. Y prime equals x squared plus 1 over x minus 1. And then you have to integrate again. So y is equal to the integral of x squared plus 1 over x minus 1 dx.
Okay.
So use your power rules again, at least for the first one, x cubed over 3. The second one is the natural log of the absolute value of x minus x plus c. And then you use your next initial condition, y of 1 equals 0.
Okay.
So 0 equals 1 cubed over 3 plus natural log of 1 minus 1 plus c.
Okay.
Natural log of 1 is 0. This is 1/3. This is -1, or you can think of it as 3 over 3 minus. So it's minus 2/3. So c ends up equaling 2/3. You do all that.
Yeah.
So that I'm going to write out that, but there's one more little piece. Now, since x is greater than 0, you don't need the absolute value anymore. Maybe that's a little wrinkle to this problem that the person who made it wanted you to see, but you don't need the absolute value. You wouldn't normally see that, but it is in this case here.
Okay.
So there's your final answer on that one.
Okay. So 2 times to plug in the numbers they give us. Okay.
Yes, that's why you need 2 initial conditions. Now, if they don't give them to you, like, let me just really quickly here go up to the side and say, let's say it's d squared x over dy squared. I'm sorry, d squared y over dx squared equals, let's just say it's x. Well, if you integrate this twice, you get x squared over 2 plus c, and then you'd get x cubed over 6 plus cx plus c, like that. You could leave it like that. Like, that would be okay if you don't have initial conditions.
Okay.
So
I don't think we talked about that, so I think they should give us.
Sure. Yeah, I mean, that's reasonable, but
yeah, just in case.
Yeah, just keep that in mind. Okay, number 5. Whole new problem here. All right, so number 5 is a differential equation. They're giving you the differential equation on the left. They're giving you, this is the initial condition. It's just in a different format this time.
Yeah.
And then what they want you to do is like use the whatever you come up with to evaluate it at 0.
Zeroing for X and whatever.
Yeah.
Okay.
Yeah. So the hard part here is like, well, how do you do this? Because it's integral dy equals integral sine x cosine squared x dx. This is a u substitution. Any idea which one should be your u?
I feel like it should be cosine. too.
Okay, and that is correct. Now, if you guessed wrong, you would find that it doesn't work out nicely. This one's going to work out nicely.
Okay, so if it doesn't work out nicely, probably try it again.
Yeah,
Would
try the other
be
one.
there in the U?
I'm sorry.
Would the 2 above the cosine be there?
No, it's just cosine. You
Oh.
could make it cosine squared, but that would also lead you down the wrong path.
Okay. Okay.
So like just to be like in full disclosure here, this is a form of like, these are really common questions you get asked where this one's odd and this one's even, or this one's even and this one's odd. These exponents
Yeah.
above sine and cosine, like they're classic exam questions. So it's actually, you always make it the one that's to the power.
Okay, the one that's to the power.
Yeah.
What if I got like the same question, but if cosine had a 1 above it as well and not to the second power?
And sine was to the power of 1 or sine was to the power of 2?
They're both to the power of 1. It's the same exact question.
Then you can choose either one because they're derivatives of each other. Yeah.
Perfect. Okay.
Okay.
Got it.
So you take your derivative here and you get integral sine x u squared, and then dx is du over negative sine x. And you know this works because it cancels. Like you're just left with u's.
Mm-hmm. Okay.
Okay, so then you find your antiderivative and you do say plus c, y equals that, and then you do back substitute your u. Like you cannot use your initial condition here. You have to put it, because it's not in terms of u, it's in terms of x and y.
Okay. So
So
and what would I plug X in for? U?
no, you got to put your u back in. So it's cosine,
Okay,
cosine cubed.
Then put the.
Yes, exactly.
Okay.
So the initial condition is pi over 2 comma 0. So 0 equals minus cosine cube pi over 2 over 3 plus c. And cosine of pi over 2 on your unit circle, that's up here at the top. What's the x value there? At 0.
Okay.
So this ends up just being 0 cubed over 3 or equal to 0.
Okay.
So your equation is just this y equals minus cosine cubed x over 3, and then they want you to evaluate it at 0. So you just plug 0 in and you have to evaluate that on your unit circle. Cosine of 0 is 1, so it's negative 1 cubed over 3.
Okay. So it'll be negative 1/3.
Yeah.
Okay. Perfect. And I just leave it as y equals negative 1/3.
Yes, that's your final. Like if there's only one box for the answer, that's it. Even though there's a lot of other steps to get there.
Yeah. Okay. Gotcha.
Okay, question 6 is way too difficult to be done by hand by a first year calculus student.
Okay.
Um,
We can skip it.
well, we can do one. We can just do one like it. That's like this is what I would think would be somewhat reasonable, although there's other options here, is just saying that dy dx equals x.
Okay.
Okay. And what that means is, in words, it says the slope, the slope is always the x value.
Yeah.
Okay, so like, and there's, you really want, okay, so if a slope of 0 is a horizontal line, a slope of 1 is this 45 degree, and a slope of -1 is minus 45 degrees.
Mhm.
So you tend to kind of like want to pick values for x that become these values.
Okay.
So like along the y-axis here, x equals 0. So when you put 0 in for x, dy dx, which is the slope is 0.
Mhm.
So there, that means there's horizontal lines all along here.
Okay.
In
Okay.
this next spot, do you see that x is equal to 1? Any point along here, x is equal to 1. Well, that means dy dx is equal to 1. Dy dx is a slope of 1. So that looks like this.
Okay.
So because dy dx in this problem equals x, the slope is always the x value.
Okay.
So when x equals 2 along here, the slope is now 2. So it's just steeper than these.
Okay.
Okay, and then over here, this line over here,
The
or this
reflection
negative,
of the other one.
it ends up being a reflection, but it's because it's x is -1, so it's just this down into the right one. And then over here, it's -2. So this, we could spend a lot of time on slope fields because it's actually a really interesting topic, but this one in particular is much more complicated than you would ever see, because it depends on both x and y in the example there. Now that we can do it, but it's just more a problem. So let me actually really quickly go and graph it for us.
Okay. Kind of just be plugging the points into that equation.
Yes. And
Okay.
then whatever it is, you have to write that as a slope. So if you don't get a nice number, it becomes kind of a tough one to do.
Yeah.
Is it y minus 1 squared?
Right.
What is it there? Trying to find it again. Yeah, at y minus 1 squared. This one's not all y's in the first quadrant. Just give me another 30 seconds here and I'll have it up on the screen for you. It's worth looking at. Okay, so let me snip this in. All right, so to do the actual one this is what it would actually look like, and there's a little more resolution than you can do, but it's a fair amount of work to do this. But it is possible. It is, like you said, just plugging in the points. So we need this for part B. Part B says, like, explain why the solution that's shown, the image that's shown, it could not be the solution. So I didn't say that very well. When you look at B, and I'm going to snip it in here, what type of graph do you see? What is this the graph of, in your opinion? Like, I think it's a parabola.
Yeah.
It also goes through 0, 0. Okay, so if like the idea with slope fields is that you can like sort of trace a solution just by following kind of the tangents like there. But the problem is like something seems to happen when you get to this point right here and then here.
Yeah.
So there's actually nothing that goes through the origin, which is what this question is trying to ask. It's trying to get you to say like, hey, nothing is going through the origin, so that can't be it. But also on this side, see how the answers sort of tend to be no longer parabolas. There's sort of this upside down Gaussian curve. Maybe you've seen that in another class, you know, that, and that's different. And they even maybe just go down like this.
Yeah.
So if this were a solution, then so would this, and so would this, and so would this. But it's not. Like the graph on the left looks very different than that on the right.
Mm-hmm. Okay.
Okay, so part C is to actually go and solve this differential equation, and it looks more complicated than it actually is. You actually do know how to solve this one. So we're gonna work on that together here. It's another separable one, and that means you separate the variables. You move the y's left. So in this case, you're gonna divide both sides by y minus 1 squared.
Okay.
And then this dx, you sort of multiply, so it moves to the right. So on the left, you have integral dy over y minus 1 squared equals integral x dx.
Okay.
Is there anything about that that you would like me to cover again?
No, I get that.
Okay, so on the right integral is not too bad. On the left, it looks hard, but let's just say you said u is y minus 1.
Okay.
Then du is what? What's the derivative of the right-hand side? It's just dy,
Okay.
right? Because it's y to the 1, like you treat a y like it's an x, derivative of x is 1 or derivative of y is 1, so it's just a dy.
Yeah.
So this becomes dy, well, instead of, let me not write dy, it becomes 1 over u squared, and then instead of dy, you write du. And this is u to the minus 2. Yeah, it looks more complicated than it actually is, and that's the challenge at this part of the course is like, do you see it or not? And you can make a u substitution, but you actually don't need to. Like you'll eventually be able to do this without that. But if you need to, do it. Write out the u and take the derivative and back substitute.
Yeah.
So when you take your antiderivative of this, it's u to the minus 1 over minus 1 plus c equals. And then on the right-hand side, it's just x, so it's 1/2 x squared. And actually, let me move the c to the other side because that's generally where we put it.
Okay.
Okay, now on the left, this simplifies to -1 over u, but what was u? U was y minus 1.
Yeah.
Equals 1/2 x squared plus c.
Let me plug
And
the number.
yeah, you were given this, you were told f of 0 equals -1. So that means that y is -1, -1 over -1 minus 1, 1/2 0 squared plus c. And you get 1/2 equals 0 plus c. So c is 1/2. So your final answer is, well, actually, we can do a bit more. Your final answer is this line up here, but c is 1/2.
Okay.
Okay. Now this is correct, but it's not like it's not solved for y.
Okay.
You could be asked to do that.
Okay.
And I mean, that's kind of awful, but like that's where you're at here.
Yeah.
So you tell me if you want us to do that. We can also do the next part of the question, maybe, if you want to do it. I'm sorry, I didn't catch that.
It's fine. We can leave it.
Okay, so part D says to find the range of the solution. This is not a calculus question. It's not a calculus 2 question, but I mean, it could show up. So on the AP, sometimes they ask you questions that aren't really calculus questions, but to find the range, you would need to know what the graph of this looks like.
Mm-hmm.
And you may or may not be able to without graphing it. Do you think this is going to be on your exam?
No.
Okay, then we should not do it. Okay. Let's see here. Are we on, was that 6? Yeah,
Yeah,
6.
7.
Okay. All right. I'm just looking ahead here. I'm trying to make sure we'll get through everything.
Yeah.
Okay. Question 7A is to determine the equation of a tangent line given this thing here.
Mhm.
Actually, I guess I need to snip it all in. Okay, it says here's a differential equation, and they want you to find the equation of the tangent line. So if you haven't done this in a while, you may or may not remember that like you already have a lot of information here to be able to do it.
Mhm.
For the tangent line, you need y minus y1 equals your slope, x minus x1. And you need two things. You need a point, which comes from right here. That's your point. And the second thing you need is a slope, which comes from the derivative, which is right here.
Mhm.
So your point is 3 comma -1. Your slope comes from taking that point and plugging it into the derivative. Now, usually you have to find the derivative, but here it's already given. So your slope is dy dx, which is instead of x squared, or instead of x, you're going to plug in 3. And instead of y, you're going to plug in -1. 9 plus 3 minus 5 is 7. 7/1. So your slope is 7, and your point is 3 -1.
Yeah.
So the equation of the tangent line is y minus y1, y minus a -1 equals your slope, 7 x minus 3.
Yeah.
And that's it. If you were putting this on the AP, you would just leave it like that. On your exam, it's up to your instructor how they want it, but that's usually good enough.
Okay.
So part B is much more complicated.
Yeah. Is it kind of what we did in, what is it, 4B?
Look, did we do that today?
Yeah, there's the first one we did.
No, because we're 4B is going backwards with antiderivatives. This one is actually something you would have seen at like chapter 3 of your class, where you
Oh, okay.
so the first derivative is given in this. It's given right up here. This x squared plus x. Let me write it down. X squared plus x minus 5 over y plus 2.
Yeah.
That's given.
Mhm.
So to find your second derivative, you have to take the derivative of the right-hand side. The derivative of the right-hand side is quotient rule,
Mhm.
which is awful, right? You got u over v prime. It's bottom times root of the top minus top times root of the bottom over the bottom squared.
Mhm.
So the bottom is y plus 2 times the derivative of the top. The derivative of the top is 2x plus 1 minus the top, x squared plus x minus 5 times the derivative of the bottom. So this is where it gets a little bit more challenging. The derivative of the bottom is 1, but because it's defined implicitly, you would write y prime as the derivative of that.
Okay. Gotcha.
Okay, over the bottom squared. So they want you to again plug in this 3 comma -1, which is fine. You know how to plug those in. The only thing you may not know is this right over here, this y prime. That comes from part A. It's the slope.
Oh, okay.
It's 7. Like you already did that in part A. You know, that's y prime there.
Okay. Okay.
So I'll just make a note here that y prime is 7 from part A. So you plug the numbers in, you get -1 plus 2, 2 times 3 plus 1 minus 3 squared plus 3 minus 5 times 7 over -1 plus 2 squared.
Okay.
This is 7, this is 1, 7. So what I do is I sometimes write the answer above it, so I don't have to keep writing stuff. This is also 7 times 7, 49 over that. That's 1. So it looks like it's negative 42. And if you can do all that, I mean, you're really in good shape. You really understand a lot of things if that's possible.
Yeah. Okay.
Okay. So let me get back to. Okay, find an integral equation such that I'd like to skip 8 unless you really want to do it. I moved to 9.
Yeah.
8's out of scope for what you're doing. But 9 could be also. Did you learn Euler's method?
Yeah.
Oh, you did. Okay. Well, all right. Well, let me go. I gotta go find it. This in the real world, you use calculators for this if you're ever asked to do it.
Okay.
So I gotta go find the formula for it. Okay, so the formula is this. So it's the next point equals the previous point plus something t minus t0 here. And I want to just remember what we got here. So this comes from this is basically your derivative. This is your, well, I'll just write it, your derivative.
Okay.
Okay, so your original like x and y is here. So your like y0 is 0, and so your y1 is 0 plus, and then you get your slope from up here. So you're in your problem, it's going to be 1 minus whatever the y value is, which is 0, times 2 step size of equal size. Usually they have to tell you. Oh, this is going backwards. Huh, that's interesting. So your equal step sizes. So here, this is x equals 0, and you're given x equals 1. So your step size is going to be 0.5, except you're going backwards, which is odd. You almost never do that. So
Okay.
so your T1 is 1, and then minus. I'm sorry, your T1 is 0.5, because that's your next step. Like think you're starting at 1, you go to 0.5, and you go to 0.
Mhm.
So this is your T0, this is your T1, and this is your T2.
Okay.
So it's really odd, but I mean, this is the formula. So to like, there's a lot of variables here, but basically you take your previous answer, and then you have to find the slope. The slope comes from the differential equation. And then this is the distance between the 2 points. Now, normally if you're going forward, like if you're going from 0 to 0.5 to 1, this is always positive, but in this case, it's negative.
Okay.
So the answer here is that 0 plus 1 times minus 0.5 ends up being minus 0.5. So that's your y1.
Okay.
Your y2 is your y1. See, it's your previous, your 2, 1 plus f of, and now you try t1 comma y1, and then it's t2 minus t1. So like these indexes increase, but okay, so you take your previous answer minus 0.5 plus you got to find your slope. Your slope comes from the differential equation. The y values is the y value of here, and that you just calculated. So it's if you remember this is really 1 minus y. So it's 1 minus your y1 minus 0.5. And then your T2 is 0 minus 0.5.
Okay.
I wouldn't expect you to follow that. This is not a good question to do for like first time learning this, or even second time, but it's that. So notice the T2 minus T1 or the T1 minus T0. That's always going to be the same in your problems. Like whatever you end up coming up with, that's always going to be that number, because you're chunking through it. Like your difference between points is always the same. The derivative is what changes in the previous value.
Yeah.
Okay. So y2 is minus 0.5 plus 1.5 times minus 0.5. Well, I shouldn't have that. That was minus 0.75 minus 0.5. So it becomes minus 1.25 for your y2. And that's your final answer.
Okay. Okay. Gotcha. A little bit confusing, but I follow the pattern.
Would you like to do another one that's maybe more straightforward?
Yeah.
Okay. So let's say dy dx equals x over y. Okay. And I tell you that f of 1 equals 1. Okay, I have to tell you that. And I have to tell you, like, you're trying to approximate, I want you to approximate f of 3 using 2 steps.
Okay.
So your T0 is 1, your T1 is going to be 2, and your T2 is going to be 3.
Okay.
Does that make more sense?
Yeah.
So y1 equals y0 plus, and for some reason they use f here. This is really f plus f of your x0 comma y0 times T1 minus T0. Well, they use T, but it's really your x.
Okay.
I guess maybe let me do this T over y. So here's what it is. This is your differentiation. Your y1 is your y0, which is 1, plus you have to put your t and your x, which is 1 and 1, into this equation. So that's 1 times 2 minus 1.
Okay.
And you get a number out of that. You end up getting 2.
Okay.
y2 is equal to, and this is where you got to pay attention to the indexes, y1 plus f of t1 comma y1 T2 minus T1. But you already have y1. y1 is your previous answer. y2 equals your previous answer plus, and this is maybe the hardest part, you have to stick the previous answer for y and the t value you're using, or the offset, into this differential equation. So in this case, it ends up being 2 over 2 times 2 minus 1.
Okay.
So you get 2 plus 1, which is 3. y3 equals, where's that? We're trying to approximate, f of 3. Okay, y3 is y2 plus f of t2 comma y2 over t3 minus t2. So it's your y2, which is 3, plus you have to take the t value you're at, which is now 3, which is the same as that. So this one kind of was boring because it always ended up being the same value, but
Okay.
you can see this. So this ends up being 3 plus 1, which is 4.
Yeah. Okay.
Let me send you a link to a reference that I use for this. Try to look at the example problems that are probably more useful than reading the text.
Okay.
Unless you need trouble going to sleep at night and you want to read boring math text. Okay, so we knocked that one out. Let's see what's next on your practice exam here. Calculator is okay now. All right. Oh no, we have find the particular solution to the differential equation. Let's do that real quick because you will get, like, it's reasonable to ask you to do this on the exam. So it's kind of unrelated to Euler's method. It's just, hey, solve this differential equation. So
Yeah.
you would divide both sides by 1 minus y, and the dx would move over here. So you have integral dy over 1 minus y. Make sure you put that on the bottom, equals integral dx.
Okay.
So on the left, you could make a u substitution. You could say 1 minus y and du is equal to minus dy. You could do that because it becomes the integral 1 over u, and then instead of dy, it's negative du, which becomes negative integral 1 over u du, negative natural log absolute value of u. Okay, you followed all that.
Mhm.
Okay, and then you got to put your u back in. So that's it's minus natural log absolute value 1 minus y equals, on the right hand side, if I scroll up here, it's just the integral of dx. So that becomes 1/2 x squared plus c. And then they give you an initial condition right here. That's x, that's y. Minus natural log absolute value 1 minus 0 equals 1/2 1 squared plus c. The natural log of 1 is 0, negative of 0 is 0, 0 equals 1/2 plus c, so c equals minus 1/2. And then you throw that back into this line right here. And this is where, this is up to your instructor. Do you need to solve this for y? You can solve it for y, but you're also sort of done.
Okay. I'm not sure what.
Let's just go through this one, how you would solve it for y, because this one's got a few things that are maybe a little bit less clear. So the negative you would move over, natural log absolute value 1 minus y equals 1/2 minus 1/2 x squared. So I negated both of them and just reorganized it. And then here to undo ln, use e and e on both sides. On the left, it becomes 1 minus y. Okay, but you can actually drop the absolute values because they're no longer needed. On the right, you have e to the 1/2 minus 1/2 x squared. Okay, and to solve for y, you can do a lot of things. I find it best to add y to both sides, and then you're going to subtract this over to the other side.
Okay.
So, and then you flip it, so it's y equals 1 minus e to the 1/2 minus 1/2 x squared.
Okay.
None of this is calculus, but it's part of the problem. So just be aware that could be expected of you.
Yeah. Okay.
Looking at this next page here, 10 and 11. Is there a 12?
Yeah.
Okay, let's look at 10. So they give you a lot of words here, but the thing here that you're focusing on is this is your differential equation. dl dx equals minus kl. So in this problem, L is like Y. So you want to move the L over to the other side and move this dx over here. So it's integral dl over L equals integral minus K dx.
Okay.
All right, so how do we solve this? Well, we have to integrate the left-hand side. This is the natural log of the absolute value of L equals minus kx plus c. Is that okay so far?
Mhm.
All right, so if you read the problem again, it says, as a diver, you know from experience that diving to 18 feet, 18 is the value of X. The intensity is in half. So we could call that 1/2 L.
Okay.
But we really would like to know how much they started with. So what to suggest here? We know that at 0, we can call it 100% of intensity. That might be a good thing to do here. Problem is, I don't know how it's going to work here. So let's just carry this calculation on a little bit further by solving for L. So you're going to E both sides here.
Sure.
And the way this works is on the left side it becomes L. On the right side, it's e to the minus kx plus c, okay, which is great, except that we've got two constants here. This right-hand side can be rewritten like this, minus kx times e to the c, because when the bases are the same, you can add the exponents, which is what we're doing here.
Mhm.
And then you can come over and say, oh, well, e to the c is really c. So this is e to the minus kx times c. And then most of the time you see that out in front. So it's ce to the minus kx. So L is really equal to this. Now, that didn't help much, but it kind of does. So they don't tell you the initial intensity. So you've got to almost pick a number. You got to say, like, this is the initial intensity. Either it's I or you give it a number, and probably a number is going to be more helpful.
Okay.
But we'll have to account for that. And that's the weakness of this problem. Like, either a student did this, or this is, like, I think you said students, or they took this from a textbook that was really emphasizing more challenging problems where you don't have this information.
Yeah.
Okay, so but we're going to go with that. So here's how that works. 100 equals ce to the minus k times 0. That becomes e to the 0, which is 1. So c equals 100, which goes right back in there. And all we're saying is that the intensity at 0 is 100%. Like, 100 means in this case 100%.
Mhm.
Now on to the next part where it says that when you dive to 18 feet, the intensity cuts in half.
Okay.
So cuts in half means at 18 feet, it's 50% or 50.
Mhm.
So we can say 50 equals 100 e to the minus k times 18. And then we solve for k. So you divide by 100, you get 1/2 equals e to the minus 18k. You take the natural log of both sides. On the right side, it undoes the e. So you get natural log of 1/2 equals minus 18k. So k equals minus 1 over 18 times the natural log of 1/2. And that's some number, okay? And that's why it says calculators are okay. So we did all that to go back to this equation right here, and we can now substitute in. So L equals 100 e to the minus kx, but k is this right here. It's a number. Let me
Okay.
get that number here. Minus 1 over 18 log of 1/2. It's minus 0.010129. You got to go more decimal places than you'd think here. So I just chose 6.
Okay.
So now we can actually answer the question. It says, you know that you cannot work when the artificial light intensity falls below 1/10 of the surface value. So we considered the surface value to be 100. So we're trying to figure out, well, when is L equal to 1/10 of 100, because that's the surface value. But we define that.
Yeah.
Okay, but it still works because we're using ratios in all these problems. So that's 10. So we're basically saying, okay, when is 10 equal to 100 e to the minus kx?
Okay.
So you divide both sides by 100. That's 1/10 e to the minus kx. And you do the same thing. You solve for x this time though. So x is the natural log of 1/10 over negative k. And that k value we have. So you go back to your calculator, use that K value, log of 1/10 divided by negative K. I missed a negative somewhere. Anyway, oh, it's sorry, it's positive. So K ends up taking a sign here, so it's positive. Anyway, as a result, you get 227 feet
Okay.
when you do all that. Did you do any problems like this in class?
I think we did a few, yeah.
Okay. Because the 11 is, it's similar. You end up having to solve a differential equation,
Okay.
things like that.
Okay.
We got some time here. Let's do 11. This is like the same question that is given at Arizona State's differential equations exam. So I don't know why it's here.
Mm.
All right. So they give you a differential equation again, which is where your focus should be. It's okay, great. And they say at time 0, 10% of the townspeople have heard the rumor. Okay. So it's kind of the same problem here. You don't know how many people are in the town, but we can solve this differential equation. So by now you should say, okay, I kind of get this pattern here. We got to move the y's to the left and the non-y's to the right. So on the left, this is a partial fractions. And you normally would do that A over B stuff here, but it ends up just being 1 and 1.
Okay.
So why is that important? Well, it makes it faster to do. So you get the natural log of the absolute value of y plus the natural log of the absolute value of 1 minus y. But because there's a negative inside here, we're talking about that yesterday a little bit, you put a negative out in front, equals 1.2 t. And then you can actually do the following. You can make it y over 1 minus y using your properties of logarithms. You can e both sides. So you get y over 1 minus y equals e to the 1.2 t, okay, plus c, plus c. So that goes here, and then the c ends up coming out in front like that. So this is the point where you'd want to establish an initial condition. You want to say initially, they say 10% of the town's population know it. You would really need to know how big the town is.
Okay.
And we don't know, but let's just say there's 1,000 people in the town. So then 10% of it would be obviously like 100.
Yeah. Gotcha.
So you use that to find C, and then we can answer some of these other questions. So what we did is part B. Okay, but part C is actually done from the original here. And I don't know how to tell you to answer that other than to use like a slope field.
Okay.
But I don't know how else they've been talking through. So I would focus on solving the differential equations, not necessarily all the other stuff that goes along with it.
Yeah.
We do
Okay.
have to stop here.
Okay.
Hope this was helpful. Thank you so much for scheduling, and I'll send you the notes here shortly and see you next time.
Okay. Thank you.
You're welcome. Bye now.